variable than the one in our equation. We'll say the absolute value of some variable r. There's two different possibilities because absolute value is distance and we can go the same distance in two different directions. There's two different parts or two different pieces to the absolute value definition. The absolute value of r is just equal to r if r is greater than or equal to 0. In other words, if there's a positive number inside the absolute value, then the absolute value and the number inside are going to be exactly the same. The other possibility is that the absolute value of r is equal to the opposite of r, if r is less than 0. So either what is inside the absolute value is exactly the same, or what's inside is equal to the opposite of what's outside. Taking both of these ideas into account, we can use those definitions or use those ideas to set up our two equations. We can start by saying that what is inside the absolute value is exactly equal to what's outside. So that would tell us that the x minus 2, what's inside, is exactly equal to what's outside, 2x minus 7. Or, my other possibility is that what's inside is equal to the opposite of what's outside. So what's inside the absolute value could equal the opposite of what's outside. That would look like taking x minus 2 and setting it equal to the opposite of 2x minus 7. To take the opposite of a quantity like that, you take the opposite of each individual term. So that would be negative 2x plus 7. If I solve both of these equations then, I can subtract the 2x. That gives me negative x, or negative 1x minus 2, equals my 2x's cancel, negative 7. Add my 2 to both sides. I get that the opposite of x is equal to negative 5. Divide by negative 1, which tells me that x is equal to 5. Or, over here, I could add the 2x to both sides and get 3x minus 2 equals my 2x's cancel, 7. Add the 2 to both sides, and I'm left with 3x equals 9. Divide by 3, and I get that x is equal to 3. X equals 5 and x equals 3 are possible solutions. Because my original problem started off with variables both inside and outside the absolute value, I have to be very careful about the solutions. It's possible that my solutions do not make the equation true, so I have to go back and check them. So if I check x equals 5, check x equals 5. I check it by plugging it back into the original problem. That would give me the absolute value of 5 minus 2. I take out the x and put in the 5. Equals 2 times 5 minus 7. Well, 5 minus 2 is just 3, so I would get the absolute value of 3. Equals 2 times 5 is 10 minus 7. So I'm told that the absolute value of 3 is equal to 3. That is true. Because that makes a true statement when I plug 5 in for x, then x equals 5 is a solution to this problem. Now I have to check my other solution, x equals 3. Let's check x equals 3. Again, it has to work in the original problem, so we'll go back to the original problem. Instead of saying the absolute value of x minus 2, I'll say the absolute value of 3 minus 2 equals 2 times 3 minus 7. So this gives me the absolute value of 1 equals 6 minus 7, which tells me that the absolute value of 1 is equal to negative 1. Well, the absolute value of a number is never negative, so this does not work. This is not true. Since plugging 3 in for x makes a false statement, then I have to throw out 3 as a solution. The only solution to this particular problem is x is equal to 5. Please don't forget to check whenever you have variables both inside and outside the absolute value. Let's look at another one like that. The absolute value of 3x plus 5 equals 2x plus 6. Well, again, going back to that definition of absolute value, we can start by setting what's inside, the 3x plus 5, exactly equal to what's outside, 2x plus 6. Or we can take what's inside, the 3x plus 5, and set it equal to the opposite of what's outside. I have to take the opposite of each term. So instead of positive 2x plus 6, that would give me negative 2x minus 6. Solving both of these equations, I could start by subtracting the 2x from both sides. 3x minus 2x is 1x plus 5 equals 6. Minus the 5 from both sides, I get x equals 1. So one possible solution is x equals 1. The other possible solution I could find by adding 2x to both sides, which gives me 5x plus 5 equals, my 2x's cancel and I get negative 6. Subtract the 5 from both sides, and I get 5x equals negative 11. Divide both sides by 5, and I get x equals negative 11/5. So my two possible solutions are 1 and negative 11/5. I have to check both of those. So if I check x equals 1, that gives me the absolute value of 3 times 1 plus 5 equals 2 times 1 plus 6, which gives me the absolute value of 3 plus 5 is 8, equals 2 times 1 is 2 plus 6 is 8. The absolute value of 8 equals 8. That is true. So that means that x equals 1 is a solution. If I test negative 11/5, I get the absolute value of 3 times negative 11/5 plus 5 equals 2 times negative 11/5 plus 6. If I simplify, this gives me the absolute value of negative 33/5 plus, I'm going to go ahead and just write this with a common denominator of 5. 5 is the same as 5 over 1, so 5 over 1 is the same as 25 over 5. Don't get thrown off by the fractions. Equals 2 times negative 11/5 is negative 22/5. Again, 6 is 6 over 1, so if I rewrite that as a fraction with a denominator of 5, I will get 30, that's a 30, over 5. Simplify this a little bit more. The absolute value of negative 33/5 plus 25/5, well, negative 33 plus 25 is negative 8, so this is negative 8/5. Again, please do not get lost in your operations with fractions. Equals negative 22/5 plus 30/5 is positive 8/5. The absolute value of negative 8/5 is positive 8/5, so this also makes the problem true. Negative 11/5 is also a solution. So in this case we have two solutions, which would be negative 11/5 and 1. Again, please do not get lost with the fractions. Review your operations with fractions if you have to, but don't lose sight of the fact of the overall concept.